How small is too small when considering a p-value? So what the real question here is, how small does p need to be in order to reject our null hypothesis? So we've used a lot of examples where the p-value is quite large, say 0.18 to 0.5, and a lot of examples where the p-value is very small, 0.0000001. In both of these cases, it was clear that the probability of the data given the null hypothesis, the definition of the p-value, was either relatively likely, and so we shouldn't reject, or very unlikely, and we should reject. The question is, where in between those extremes does the line fall? There are some very common values for this cutoff, and they're often referred to as alpha, here shown as the Greek character alpha. So these common thresholds are 0.1, 0.05, 0.01, and 0.001. Exactly which threshold is used depends on the discipline. Psychology tends to use things closer to 0.1 more often. Physics can often use values even smaller than 0.001. This largely has to do with what exactly it is they're interested in testing. We'll cover more on that in a moment. 0.05 is by far the most common alpha threshold used, and this is for relatively bad historical reasons. That's all we need to worry about for this class. For most things we'll use, p of 0.05 is a good threshold. However, it's important that you set this threshold before running your tests. You can't run a test, get a p of 0.08, and then say, well, I was always going to use an alpha threshold of 0.1. You need to make sure you've set that up ahead of time. However, you must always look at the value of your p-value when interpreting the value. The difference between a p-value of 0.051 and 0.049 is not magically having one of them become absolutely true and absolutely the null hypothesis being false in the other one. There's a scale, and it's important that we consider that closely when interpreting what the p-value actually means.